All right, so this is gonna be quick check. Let's see, 5.2.1.b. Raise this up a little bit. This quick check is regarding a combustion reaction of C2H6. So one way that you might be given this question is it will say C2H6 combusts. Balance this reaction. All right, so in a combustion reaction, a hydrocarbon combustion reaction, this is hydrogen and carbon containing stuff, we're gonna react it with O2, and you're gonna form CO2 and H2O. All right, so now we just have to balance this reaction. I tell you in lecture, and I'll tell you here, the best way to balance this reaction is remembering one thing, and that's CHO. You could balance technically the carbon or the hydrogen first. It could be HCO, but I like CHO because it sounds cool. The oxygen, though, we're balancing last. Why that is because it's all alone. We always want to balance the thing that's alone last. Another thing to pay attention to is that oxygen's also over here and in this one. So it's in these two things, which makes it a little bit difficult to balance. And even though we usually balance the most difficult thing first, when it's alone, it's going to be really easy to figure out exactly how much oxygen you need in the end. So again, when you see combustion reactions, you want to CHO it up. And so let's go ahead and begin. Our carbon, on our left-hand side, we have 2. On our right-hand side, we have 1. 2 divided by 1 is 2, so we put the 2 right there. Now our hydrogen, on our left-hand side, we have 6. On our right-hand side, we have 2. 6 divided by 2 is 3. That resulting answer we put there. That gives us 6. Now we get to oxygen. On our left-hand side, we have 2. On our right-hand side, don't forget this, we have 2 CO2s. In other words, we got a CO2 and a CO2. We have a total of 4 oxygens right here. We also have 3 oxygens from over here for a total of 7. What do? You don't break the process. 7 divided by 2 is what? 3.5. You put that right there. Now, in your future chemistry classes, this would be considered a balanced reaction. However, we ask you to do a whole number balanced reaction. So what you're going to do here to get rid of this halvesy is you multiply everything by 2. You don't just multiply this by 2. That would make it unbalanced. But if you multiply every single one of these by 2, you're going to get a balanced reaction. So let's take this whole thing and multiply it by 2. In other words, now it's 2C6 or C2H6 plus 7O2, yielding 4 CO2 and 6 H2O. And that should be your answer. Now the next question, part B of this, is SiO2 plus carbon, yielding silicon carbide and carbon monoxide. All right, now this is really similar to the last problem in that here we have carbon that's all alone, but it's broken apart over here and here, just like the oxygen was all alone and then broken apart. So that one we want to balance last. All right, so we know that we're going to balance carbon last. Let's look at the other things that we have here. Silicon over here, I got 1 and 1. There's no difference, so I wouldn't balance that. But oxygen here, I have 2 and 1. So it looks to me like I'm going to balance oxygen first, then silicon, then end in carbon. Let's start with oxygen. On my left-hand side, I have 2. On my right-hand side, I have 1. 2 divided by 1 is 2, so you put a 2 there, and now you have 2 oxygens. Then we're going to move on to our silicon as noted. And the silicon on the left-hand side, I got 1. My right-hand side, I got 1. We didn't change anything. And then we go to carbon. On our left-hand side, we have 1. On our right-hand side, we have 1 plus 2 over here. So a total of 3 carbons. 3 divided by 1 is 3. So we put the 3 there, and we should be balanced.